There's several ways to make a metal stamping, and one way is called single stage forming. The way that you would make single stage forming part is you would take a blank, which is shown right here. You can see we would take a rectangular piece of metal pinned around 4 pins, and then we would cut this shape out of it. And then we would take the cut shape, and then we would pierce the holes in it. So we would take this shape, and it would look like this, and then we would pierce the holes, and then we take this and we advance it over here, and we put this little bend in it, and that would be there. And then we take the final form and we reform it, and we put the 90-degree bend. And then what you have is the finished product right here. And what this shows is the stages that you go through: the blanking, the forming, and the forming. And the way that we determine which process we use is based on volume. For example, this is a single stage forming. We would use this for low volume or prototype tooling. If you wanted to see if a part's going to work and you needed 100 pieces, this would be a way that we would make a part. The plus side of stage tooling is that it allows you to try out your parts before you commit to a production tool. The negative side of stage tooling is the part price tends to be high. The tooling cost is low, but the part price is high. So if you needed 100 pieces, it would make sense. If you needed 100,000 pieces, it wouldn't make sense. Now what we're showing here is the same bracket made in a progressive die stamping. You can see here that the geometry is the same, but the stamping process is significantly different. What we do here is we come in, we pierce all the holes, or what we call the flat pattern in the U shape. And then what we've got here is a flat pattern of this bracket right here. If you were to take a hammer and flatten this out, this is what it would look like. And that's what this is doing, creating the flat pattern. What the gray area here is the amount of material that gets removed to have the flat pattern left over so that we can form it. And then, unlike the stage tooling, this is actually connected to the material. This is what's called a carrier tab or a carrier strip. The stage tooling is actually manually transferred from one form stage to the other. This is not manually transferred. It's transferred by the fact that it's attached to this carrier. And then when this carrier advances to this point, at this point the part is complete. It is separated. This becomes scrap, and what you have left is the part here, which is this finished part here. Now we would use this method of stamping when your volumes dictate it. If you needed to run 100, 200,000 parts, this would be the method that we would use. And the reason we would use this method is because the part price would be significantly lower than if we used stage tooling. I talked about the advantages and disadvantages of stage tooling over progressive dies. Well, the advantages I said about stage tooling is that you get to spend very little tooling but a higher piece price. In this case, you do the opposite. You spend a little more money for tooling and a significantly lower price for the part. Now, I'm going to show you what happens to metal as you begin to pierce a hole or make a cut in it. What happens to metal is this is a hole that we're going to put in the metal. And what the stamping process does is it comes in and it punches a hole through the metal. But as it makes contact with the top, this is what's happening to the metal. It's called deformation or elongation. When we make contact and we begin to put pressure, we deform the top part of the metal. In the illustration here, it's exaggerated. You wouldn't even be able to see this with your eye if you were to look at a metal stamping, but this is exactly what's happening. This is called entry deformation. As you pierce through, you cut about 33% or a third of the material thickness cuts, but the pressure generated gets to be so great that instead of cutting, it just blows out the bottom. And then what you have is you have a hole that looks like it's straight, but it isn't. It's only straight for a portion, and then it tapers out. So this diameter of the hole is slightly smaller than the outside. Again, as I mentioned to you earlier, this is an exaggerated illustration. This is considered what we would call the roll side of the stamping, and the bottom side is considered the burr side or the edge side. And if you were to pick up a stamping, you'd be able to feel that with your fingers. You'd feel the smooth side, and you'd feel the sharp side. The smooth side would be the side where the punch enters, and the rough or the edge side is where the punch extracts. Now, this is the forming method that we use for forming steels. Low tensile steels like cold roll, brass, copper, those types of steel tend to have memory or set. I'm sorry. They have no memory. So whatever form you give them, they take. So for example, if we were forming a U shape like this out of low carbon steel, we could take a lower form that's shaped like this, an upper form that's symmetrically opposite, put a piece of metal in there, bend it, and when we separate it, we would have this shape. What happens with high tensile material like stainless steel and some beryllium coppers and some heat-treated metals is they do have memory. Unlike the low tensile, they don't set. So you would take high tensile material and you form it in this shape. When you separate the two pieces, the metal will have a little bit of memory, so it'll flare open. So what was originally bent 90 degrees, when you let it go, winds up being an angled shape. And this is what you desire. So what we have to do in that case, and we call this spring back. It means that you form the material to a certain position, but when you let it go, it springs back. And so what we do in this case is we compensate for the spring back. So we have to take high tensile material and form it like this. We form it down with the U, and then we take the two vertical legs and we overbend them. And then when we release the tooling, the legs will have their memory, and they'll open up, and this one will open up, and they'll open up to this shape. So this geometry, this angle is calculated based on the amount of spring back that that particular metal has. In a progressive stamping die, this is how a part is generated. I want to show you, because I mentioned earlier that we have progressive die forming, and we also have slide forming. And what I'm doing now is I'm going to compare the two processes to each other, and again point out the advantages and disadvantages. This is a part that's generated by a progressive die. Okay, as you can see, that the generating process consists of blanking some holes, some slots, and creating a flat pattern like this. And because it's a progressive die, it's still attached right here. And you can see that we progressively, thus the name progressive die, we progressively put forms into this part. And you can see as we move forward into this strip, it begins to look more and more like the desired part here. And we start generating bends, and we come over here, we generate some more bends, and we move forward here and generate some more bends. And what we have here is the final part formed but still attached to the strip. And then what we do here is we cut it off, and then there's your desired part. Now I want you to notice a couple of things about this. You'll notice that this portion of the material here is what's called the carrier. So we create this. This becomes scrap. So we just throw this piece away, but we need it to generate the part. And that's called the carrier tab right here that holds it in place. And the reason that I point that out is because I'm about to compare this to the slide forming method. Here is another way to make the same part. The slide forming method requires no carrier. So if you look at this, the amount of material required to make the same bracket is this amount. So there is zero scrap. We only use the amount of material that's necessary to make the part. Let me back up, and you can see that here is the strip that we would want. In a progressive die, we have to cut all this away to create it. Go back to the slide forming method, and you can see that all you really need is the piece itself. And you just put the pierce holes and the rectangular shapes, and then you just form it, okay? And the question is constantly asked when we compare the two processes, why not make everything on a four slide? Why use the excessive material and go to progressive die? And the reason for that is because there are limitations to the four slide operation. One is size of the material. It can only generate material up to, depending on the size machine you have, but about 1.25 inches. The thickness is probably 3/32 to maybe 1/8 inch. Or the limitations. And the amount of feed, for example, probably 8 to 10 inches long. would be probably a standard uh, size that a machine could handle. So there are some parameters that determine whether you put it on a slide forming or a progressive die. But you can see that if you can put the part in a slide forming operation, that it saves about 25 and sometimes 40% of material utilization. And what we do here at Conner is we'll take your part and we'll determine which process best meets your need. Can we use the slide forming process to make your part? Okay, here's another example of a part that is generated from a slide forming progressive die comparison. You can see right here that we refer to this as an M spring. You can see that in a progressive die you have to notch it. So all of this gets thrown away as scrap because you need to carry it. Again, carry it through the strips, and then you're forming it. You got the finished part, you cut it off, and what you have left is an M spring. Here's the same part up here generated in a progressive die. All it requires is a rectangular piece of metal, and you form it up. So you can see that the material utilization on this is 0 scrap. And over here you probably have at least 25, possibly 30% more material necessary to generate this part. So because we have slide forming and progressive dies, we are able to evaluate your part and determine which process best suits this particular part. This is an example of some slide forming parts. As you can see that there's also some wire in here. One of the capabilities that the slide forming machine has, it has the ability to form wire. This is round wire, this is flat wire or rectangular wire, sometimes referred to. You can see that it also can make parts out of coil stock, fairly wide material. You can see that the forming process of a slide forming machine for wire is very capable. You can see it's got different capabilities for diameters of wires. This is a keeper. One of the things that you see here is a D-ring. So the slide forming is a very versatile machine, but again, it does have its limitations. And based on your part geometry, we would determine which best suits your part. This is a picture of a slide forming machine. Unlike the press, where the material runs in horizontally, the material on the slide forming machine gets fed from this area here, which is called the rollers, and it's actually sitting vertically. And it feeds through, this is the feeder. This feeder advances the material into this area, which is called the ram. And then from there, it advances it to the forming stations, and then the geometry is formed. And what you're about to see is a video of a slide forming machine generating a part.